Good day. In this video lesson, we'll be having another topic in grade 11, General Mathematics. The topic is the inverse of a one-to-one function. Let's start. So the objective of this lesson is, at the end of the lesson, the students should be able to determine the inverse of a one-to-one function. Now, before we go into the problems, let's have these important concepts first. So it's very important. The inverse of a function is denoted by the relation set of all ordered pairs x, y such that x is f of y. So we'll be having this as we go along in detail. Next is that the inverse of a function is not always a function. So this is a common misconception. So the inverse of a function cannot be a function too. So when is the inverse of a function also a function? It will only happen if the function is a one-to-one function. So if a function f of x is a one-to-one function, then its inverse is also a function. That's why our topic is limited to this only, the inverse of a one-to-one function. If you will recall your types of function, you know that there are two types basically. A one-to-one function and a many-to-one function. So only one-to-one functions will have inverses that are also functions. So our video lesson is limited to the topic inverse of a one-to-one function only. Next, so the definition of a one-to-one function. The definition of the inverse of the one-to-one function. Now notice that if the symbol f to the negative 1. So that's not a power. That's simply a symbol to denote the inverse. It's the commonly used symbol. So the inverse f to the negative 1x is the inverse of a one-to-one function, again, one-to-one function f of x, if the following are satisfied. So the composition, you know this notation here, f of f inverse x is x for all x in the domain of the inverse. F inverse of f of x is equal to x for all x in the domain of f of x. Notice that this should come first before that. So anyway, these two must be both satisfied. Again, notice that this composition, your input function is f of x. Of course, the function will have a domain. So according to the definition, if you will compose these two functions where f of x is the input and f inverse would be the function that f of x will go through, the result will just be x for all x in the domain of the input function f of x. Same goes above. Again, these two must be both satisfied. Now what does it mean? It only means that if you notice, your input is x. So if you do decomposition, your output for decomposition is also just x2. Your input is x, your output for decomposition in the other way is also just x2. So what does it mean? It simply means that the two functions, the function and its inverse function, will undo each other. So because of this, an implication would be the domain of a function and the range of the function and the domain of the inverse and the range of the inverse would be inverses. That's why this will only apply to inverse of two functions that are inverses of each other, functions that are inverses of each other. Emphasizing on the both being functions. So the domain of the given function would be the range of the inverse. The domain of the inverse would be the range of the function, the original function, because of the definition. So anyway, let's start. Find the inverse of the function y is 2x minus 3. Now you know that y, that's also the same as f of x, right? So it can be written as f of x is 2x minus 3. This is the first recall in our concept, important concept, the inverse is denoted by this relation. So, if you recall, y is the same as f of x. So y is a function of x. Again, this is said y is as a function of x. So the inverse would be denoted by, of course, the reverse of that, the inverse of that, which is x this time as a function of y. See that? So y depends on x because y is a function of x. In here, x depends on y. So x is a function of y. So this would be your function and this is the inverse. See, the relationship is now changed or reversed. So that's why you always see this in textbooks, and here it is. The first step is to interchange. So interchange x and y, the variables x and y. So if we do that, if we interchange the values of x and y, see, y will become x. You see that? Y will become x. And x here will become y. So that's actually the first step, reversing the roles of x and y. So this is the implicit, this is the inverse function itself in its implicit form. And to solve it explicitly, we will solve for y after interchanging the variables. So let's start. It's very easy in our first example. Y, so it will become x. X here will become y. There. So we solve for y. So obviously, I can do this. 2y minus 3 is x. So that y is already in the left side. So if a is b, then b is a. So I add 3 both sides. You get 2y is x plus 3. And divide by 2. Y is x plus 3 over 2. Of course, let's rewrite our final answer. That's y, or our f of x. Then our inverse is x plus 3 over 2. Okay, so in this example, let's just show the definition, the composition, if that it works. Okay, so we have the given function, and we have the inverse of the function that we just solved. Now let's see if, through the definition, whether, so this is the definition, right here. Let's see whether these two functions are inverses of each other. So emphasizing on both being functions and inverses of each other. So you know that will only happen when you're getting the inverse of a one-to-one function. So we will test this one. F inverse x is x for all x in the domain of f inverse. F inverse f of x is x for all x in the domain of f. So we have f, and then f inverse should be x. So in the other side should be f inverse. In this it goes f of x. It should also be x. So these two must be satisfied. So in here goes the inverse. So in here goes f of x. So let's do this side first. So we have the given function. So you know the composition is the input function is the inverse. So 2x minus 3 is the f of x. So if there, then minus 3. So inside goes the inverse, which is x plus 3 over 2. So there. So you know that 2 will cancel out. So you will just be left with x plus 3 minus 3. And that's x. So as you can see, the result is x. So this is condition is satisfied. Now let's have the other one. So in this case, f inverse is x plus 3 over 2. And this is f inverse. So in here goes f of x, which is 2x minus 3. So we just simplify this. So you know that the numerator will be just 2x because minus 3 plus 3 cancels out over 2, and this is equal to x. So again, this condition is also satisfied, meaning the two functions are inverses of each other. Okay, let's have the next one. So y is x minus 3 over x plus 2. Step 1, interchange. So you have x equals y minus 3 over y plus 2. Interchange x and y. Next step would be solve for y. So solving for y here, we have to multiply both sides by the denominator, which is y plus 2 times y plus 2. So the result would be x times y plus 2. And of course, you know this cancels out. So that would be y minus 3. So we have here multiplying the left side, distributing x. So xy plus 2x is equal to y minus 3. So remember, we are solving for y. Therefore, we isolate y in one side. So here I will subtract y both sides. So we will get here xy minus y plus 2x equals negative 3. Then let's subtract again negative 2x both sides. So we'll get here xy minus y equals, here we'll get negative 2x minus 3. Solving for y, so we have to factor out y. We get x minus 1 equals negative 2x minus 3. So finally, we divide by x minus 1, so that this thing will cancel out. So we'll get y is negative 2x minus 3 over x minus 1. So therefore, our inverse, so this is our function f of x. We can write it simply like that, y inverse, or to put it more formally, if this is our f of x, then the inverse is negative 2x minus 3 over x minus 1. Okay. Now, just to show the implication of that we've shown that the domain of the function would be the range of the inverse, and the domain of the inverse would be the range of the function. We will get the domain and the range of the function and the inverse that we just solved. So let's label this the domain of the function, this domain of the inverse, range of the inverse. So the domain is easy. So here, we know it's all real numbers, except the value that will make the denominator 0, which is negative 2. Now the domain here of the inverse is all real numbers, except the value that will make that 0, which is 1. Now regarding the range, you've learned that in cases like this, when you have a rational function of numerator degree 1 and denominator degree 1, the range is simply all real numbers except the ratio of the coefficients, which is 1, and in here, all real numbers except the ratio of the coefficients, negative 2. So let's mark it, negative 2, and of course you have 1 here, negative 2x and 1. So y cannot be negative 2. Now notice that, again, the domain is the range. X not negative 2, y not negative 2. And the domain of the inverse is the range of the function. Y cannot be 1, x cannot be 1. So this will only happen if you have functions that are inverses of each other. And it will only happen if you get the inverse of a 1-to-1 function. Now, For practice, find the inverse of the following one-to-one functions. So that's it. Good day. Till next video.